Okay, hello. Today's problem 432 all of one data structure. Let me. So I solved it a couple hours ago, and I spent around like more than 1 hour, like around 1 hour, I guess. It was in the morning, so I was a little bit sleepy. Um, so let me try to solve it again, and I'll record this attempt, and we'll see if I manage to solve it within 20 minutes. Let me quickly read the problem. Okay, so um, let me sketch the solution. So we need all of one time complexity for basically a couple of operations, for all operations. So we have increment with key, we have decrement with key, we have get max, and that should return string with most frequency, and then get min, and should return string with minimal string key with a minimal uh, frequency. So it should be like key. So all of these operations should be done in like O of one time complexity. O of one. So whenever they say O of one, every time I think about either like linked list or maybe heap here, but because we have to support two operations, get min and get max, in theory I can use min heap and max heap here, but the problem is that I need to when I gonna move the element up by increasing the frequency, so I basically need to remove it from the heap. Uh, that can be like quite time consuming, and then like I'm not sure it's either like log of n to remove the uh, random element from the heap, or even if it's n, and to add the random element to the heap, I can always add it to the bottom and then try to move it up. So here NSR should be like log of log n time complexity, and it's not okay here. Get min, get max will be O of one in case of heap, but increment and decrement uh, will not be O of one. So here what I think about right now, so increment, what can increment do? It should increase the frequency for the current key if it's there. If it's not there, should add the key to our like structure. Decrement should decrease the frequency of the key, and if the frequency becomes 0, we should remove this key. And it's and get max get min if there are no uh, like 0 elements in our data structure, I should return an empty string. So this problem looks very similar to LFU cache. and yeah, LFU cache. But it's has like its own like caveats. We have like uh, only keys. We don't have values here, um, and like frequencies also. Um, kind of get max, get min. Uh, these operations, but in LFU cache, we need to just get, put, and we need also um, when we are out of capacity, we need to evict element that's has a list frequency, evict key with list frequency FK. Um, so here, because like assume that I should solve this linked list, um, so it's simple because I can like have just let's say I will have the head pointing to the maximum, and then I'll have all these elements, uh, and then tail pointing to the minimum, and then I'll have the double linked list. So this is gonna be the tail element node, and here we'll have null, reference to null, and then back we have reference to this, and back and forth. So the max, and like let's say we have like a couple of nodes in the middle. And I assume, let's say we have minimum frequency like here, like let's say 3, then we have 5, and then we have um, actual value A, and here we have B. Change the color. We have A value, we have B value, we have C value, we have D value, and we'll say we have Z value. Or not that. Let's say we have like this letter. Let's say we have like F value. And then let's say we have increasing the sequence, like here we have 8, 10, and 42. So let's assume, so whenever why this is like O of 1 time complexity for the get max, get min, it's obvious because I can always go to check the head and return the value F here, and for the maximum, and for the minimum I can check the tail, and you're gonna have like value A with the frequency 3, so it's like minimum. So the question is, why this operation is gonna be O of 1, yeah, this case, increment and decrement O of 1. So we need to kind of quickly navigate the nodes, and we have to find by the key, we have to find the node. So currently we have just a linked list, and it's not okay here because in order to find elements in a double linked list, I need to go like at maximum through all elements and return, so it's already overfan. So in order to speed up, I want to have like hash map, and for the hash map, I'll have key and as a key like string, and for the value, I'll have the node itself. So in this case, I'll have let's say for our case, we'll have 3, no, not 3, A gonna be mapped to the node A3. This is basically this one. And then B gonna be mapped to node B5. And then C gonna be mapped to node C8. D gonna be mapped to D10, and then F gonna be mapped to F42 nodes. And this is gonna be the same object. So it's gonna be the reference to the link to the node. And in this case, I gonna for the increment, let's say we already have like a key A in the list. So we try to increment for the key A, we get the node. We remove it we remove it like first, then we change the frequency to 4, um, then we put it back again. So we saved the pointer to the previous one, and we try to move it to find the place, so that the next element should be frequency should be greater than the current one. Um, so in this case, we don't move element A because like node A, because its frequency becomes 4 and it's okay. Um, so the next one, let's say we call again. So uh, first iteration, first call was increase for the key A, and the second iteration gonna be increase for the key A, and this will change this value um, to 5, and we do again. We remove it first, then change value, and then try to move it to the right, if it's possible. So we do the following. So we increment the frequency, it becomes 5. Um, and now I wanna, um, it depends how on the implementation, and I'll show you the tricks there later, but it depends whether we need to move it further. Let's keep it there as of now, but let's increase it again one more time, increment A, and then this gonna be 6 now, and then we're gonna do the following. We're gonna remove this element because we take it out from our linked list, and we check whether like it should be moved, and in this case 6 is greater than 5, so it means that we should move further, and we then check 8. Uh, 6 is not greater than 8, so it means that we found the place. So we need to break those links and then map it here. So A becomes 6, and then we do this linkage back and forth, back and forth. So we modified it, and as you can see, this is maximum like increment will either keep the element there, keep element, or we add place, or in case we wanna add element, it had never like it's not in our hash map. Let's say we add as, let's say it's gonna add to the tail this element. Let's say it's gonna be S1 and tail gonna move here, gonna be null. And um, if we keep, we either for increment we either add element um, at tail, add node and tail, so it's gonna be of of 1. Or we keep at place, it's also gonna be of 1. Or we change with neighbor, and it's also going to be O of 1. And for the, let's say we call decrement. So let's say we decrement for the S, yeah. Or let's say we decrement for the A. We get it from the map. We change its value, frequency. It becomes 5. So frequency becomes 5, and we break those links, and we try to move it to the left, and yeah, we can, it depends on the equality or not equality for the frequency, but we're gonna reinstall it back to its original place. So decrement, or let's say we decrement for the S, um, in this case frequency becomes 0 for the S, and it means if the frequency becomes 0, we should basically remove it from the tail. So for the decrement, it's gonna be of 1 also, and we should remove it from the tail, and we should remove it from our hash map. So it was as 1. We decremented for the S, we removed it from the hash map. So this is the sketch for the solution. So with this solution is based on first linked list, like double linked list, and second it's based on hash map. As that gonna reference gonna have string key, and here you have node, and value here gonna be also node, and the value node or like node list node element gonna have frequency and gonna have key. Okay, so let's code it. We have this input. So I'll have the initially I will use the tactic to not to have the sentinels in the tail and the head, and not to bother with with the edge cases when we have like empty linked list. So I'll have this. Okay, I already have such class node. So I'll have inside, I'll have public, let's say, integer. Let's figure out how many I'll have calls for the increment. So 5 to the 10 to the 4th. So you can easily deal with it with the integer frequency. And then I'm gonna have like public node right, and then public node left, and that's gonna be it. And let's say we have constructor public node, and then we have public node. Yeah, let's say we have just one constructor, and frequency equals 0, let's say here. So in the our like data, we're gonna have public node head. Let's say private node head equals new node, and I wanna pass key as empty. Frequency, I wanna initialize it with -1. To be as a marker. So head, and I'm gonna have private node tail equals new node, and then I'm gonna have private hash map string node map equals new hash map, and then here I'm gonna have public import java util hash map. Then we'll have this one. So all one for the increment. Let's say I wanna get max key. So you wanna go ahead and then for the initialization, I wanna have like head left equals tail, and tail right equals head. So have this sequence when we have like first we have tails, and we have nodes, node 1, and so on, and then have tail, node n. Something like this. And for the get max, this is the easiest one. Get max, I need to head left, and then key. And for the min, I wanna call tail right key. So that initially when we have 0 elements, head the left gonna be the tail, and when we return the key equals empty string, and the same for the tail, and get minimum we gonna have tail right, gonna reference the head here, tail right head, and the key gonna be also empty string, and we're gonna return it. So for the increment, I wanna do the following. I wanna check first if our map get key equals null. So I wanna do the following. I wanna create a node, and then I wanna, let's say, I wanna have key, string key, then int fk, and then this key equals key, this fk equals fk, fq, and then new node, I wanna pass key, and I wanna pass 0 frequency, and then I'm gonna put node, okay. If node is equals null, I'm gonna initialize it. I'm gonna put it into the map. Map put key and then node. And next, I wanna do the following. I wanna increment the frequency, node fk plus plus, and then I wanna remove it from the current um, place in the list. So let's say next right node equals node, and then I wanna have node for the node right. I'm gonna have left equals node left. I wanna also put it into next to the tail. Node left equals tail. Say node tail right equals tail right. So node left equals tail. Node tail right equals node, and then node right equals tail right, and then tail right left equals node. So I put it into the end of the link node, and then I increase the frequency, and I do the following. If so, I remove it from there, not right, not left, and then node node left dot right equals node right. And then say node current equals node right, while current frequency greater less than node frequency, I wanna do the following. Current equals current right. So I'm gonna move the pointer, and then finally when I'm gonna end -1. So that like I'm gonna go up to the head element. So current node can be maximum head element. So that um, current, then I'm gonna paste this node to the linked list. I'm gonna put the current left, say node current left equals current left, then current left equals node, and then node right equals current, and then that's it. Let's check it again. So for the initially we're gonna put the node in the tail, and we put that in the map also. We put the frequency 0. We have tail right. So tail right, and then node dot left equals tail, tail right equals node. Okay, node right equals tail right left equals node. Okay, that's okay. So then we're gonna increment the frequency, and this applies to the nodes that are already in the map or like were added here to the map. So we get this node frequency increment, and we're gonna remove that node from the linked list. So node right, node equals right, node right, left equals node left. Okay, node left. Okay. So we excluded it, then we're gonna have the pointer current equals node right, and we're gonna move the current while frequency of the current is less than frequency of the node we wanna paste, and the current frequency not equals -1, not equal -1. So the controls for the head sentinel. And then when we're gonna find this element that we need to paste it before the current. So current left equal current left. Okay, current left equals node. Okay, node right equals current. Okay, then current left that right equals node, and node left equals current left. Okay, that sounds good. So the remaining part is decrement. So I wanna get this node get. If I gonna have if node equals null, I will just push the runtime exception. So we pushed this runtime exception. If node, so I'm gonna first I'm gonna remove the node from the current. Uh, so I'm gonna have node dot right. Let's say node right equals node dot right. So node dot node So node write they. And then node left right equals node. Okay, node. Okay, for this can I remove it? And then I'm gonna repeat this but the same procedure while I will decrement the frequency, and I'll do the same procedure while current frequency is greater than node frequency. Have, let's say, I'm gonna move the current to the left, and current frequency not equal sentinel, and then we need to paste it after the current element. So current left, gonna current right equals node, but then node dot left equals current, and then current right dot left equals node, and node dot right equals current right. And then we need to check if the frequency becomes 0. If node fk equals 0, we need to map remove node remove key, and then we need to return something like this. Let me try to run this code to run it. Public static void main string args. At line 28. Hide this one. Okay, main. Okay, let me paste it to the Leetcode. Okay, so I can basically, let me check the timing for this one. So I saw it within 36 minutes, um, with some extending explanation. Um, you can always play, so you can have an argument if you're gonna have like really long middle part. Let's say we have here like elements like with A, we have frequency, let's say 8, and B frequency 8, and then we're gonna have C frequency 8, and then D frequency 8, and so on, so forth. And then let's say we have like A1 frequency 8, yeah. And let's say we have this nodes, they are linked to each other. And then let's say we kind of, and we do the following. Let's say we have like upcoming elements that has like, let's say, um, um, let's say foo key and the frequency 7, yeah. And let's say we call increment foo, yeah, something like this. In this case, if you're gonna have increment foo, its frequency gonna change to 8. We're gonna remove it from this one, and then based on this, while current frequency less than frequency, so it's gonna stay there. Let's say stay there. So foo gonna change from 7 to 8. And we removed it, we re-added it back. Let's say we do that again, increment increase full frequency. And then what it will happen, we will be moving, let's say we have like here, like 10 to the power of 4 like elements or like nodes. So we're gonna have a pointer that's gonna move it to the right. Yeah, let's say we have like here like bar, and then say its frequency equals 42. Um, so if we increment to frequency to 9, then we're gonna remove it from the tail, or like from the left side, and we need to go find the right place, and the right place gonna be here a current, yeah, element, and then we're gonna paste it right here in the current, before the current. And because we're gonna have like this 10 to the power of 4 middle nodes, then it means it's gonna be like 10 to the power of 4 operation for the increment, for the single API call. And let's say then we're gonna have this decrement, and then decrement for the foo. So after we paste it, we're gonna have this situation of gonna be here foo with frequency 9, and then you're gonna have bar with a frequency 42. And here we'll remove it from here. So let's say we call decrement foo again. The value for the full frequency gonna change to 8, and we're gonna check, okay, if we're gonna um, move the current pointer frequency while it's frequency less than current frequency. So no, we're not gonna move it. And let's say we call decrement, because like frequency was equal to each other here. And let's say we call full decrement again. And then that means that we're gonna travel back and we need to find the right place for the foo now. So we're going to change to 7. We're going to remove it from here, and then the current pointer will go back until the left element frequency will be like either -1 or like less than like new frequency 7, and like it's again off n. So potentially we can generally speaking, adding and removing element based on the frequency here, not all of one, but this is quite like synthetic example, and uh, you can see that I can always play with this equality, not equality, to figure out how I can accommodate for my pattern. I can put equality here, like less than equal, and then more than. In this case, it's based on their use case and like test cases, how they write there. If I put two equal signs here and here, let's see, again, not that good. If I change that only here, uh, you see that? So definitely, like, it depends on the situation. Either gonna be uh like large part for the large middle part, and if they're gonna be frequency gonna fluctuate back and forth, like we're gonna if the use pattern is that frequency goes like one up, then one down, then one up, then one down, or like two times increment and two times decrement. So, and if we have like many such kind of operations, we can definitely we cannot escape it, but for one operation we can escape it by basically placing, instead of greater or equal, we can place just greater, and that means that if we're gonna have like more or less, and if you have like increment, decrement, increment, decrement, then it will just stay there, yeah, because stay in the tail or stay in the head. Uh, but if we will have like this increment, then decrement, decrement, and then we have a large middle part, then it will not save us from this doing of and operations for the moving the current pointer. Yeah, I'm gonna wrap up. So I solved it, I guess, within 36 minutes. Not that good in terms of like real interview. So I will call it fail. But actually, it's a kind of hard problem, and real interview probably will be like given like a little bit more time for this problem. Hope you enjoyed it. Um, that's it.